Hello Year 9, this video goes through the answers to worksheets 15.1 and 15.2. If you found this quite easy, you can nip through the video very quickly and just check your answers. If you find these more difficult or you're getting them wrong, then I've gone through each answer in a bit more detail so you can see how to tackle them or work out what you need to get right. Good luck! Worksheet 15.1 focuses on the equation P equals VI. Don't forget for each question, what you should be doing is writing out the equation, the working, the answer and the unit to ensure full marks. So question 1 is pretty simple. P equals VI and then we put the numbers in underneath. So in this case P equals 12 times 2 which gives us 24 watts. Question 2, I'm now asking for voltage. So again I write out P equals VI and then I write the numbers in underneath. 24 watts under power, we don't know the voltage, but the current is 3 amps. I'm going to need to rearrange to make voltage the subject of the equation, so remember we do our reverse maths. 24 divided by 3 equals voltage, which equals 8 volts. Question 3, this time we're being asked to calculate the current. Again, P equals VI and we put the numbers in underneath. 12 watts equals 9 multiplied by I. Reverse maths. 12 divided by 9 equals I, divide through to get 1.33 amps to 2 decimal places. And remember 2 decimal places is enough. Question 4, very similar, P equals VI and put the numbers in. Here, we've got 230 volts mains with a current of 3 amps. So we do V multiplied by I to give us 690 watts. Question 5, we're being asked to calculate voltage. So again, we write P equals VI, numbers in underneath. 50 watts equals V multiplied by 1.25. Again, reverse maths. 50 divided by 1.25 equals V, which gives us 40 volts. Question 6. This time we're calculating current. P equals VI. We put the numbers in. 115 watts is equal to 230 multiplied by I. Again, we reverse maths. We're dividing through. So 115 divided by 230 equals I, which is 0.5 amps. So question 7 is a little bit different because we're being asked to identify which fuse we're going to put into our hairdryer. There are 4 different fuses that we can use, 2, 3, 5 or 13 amps. So what we're really being asked here is to calculate the current flowing into the hairdryer because remember a fuse will burn through if the current gets too high. We're told it's a 480 watt hairdryer and it's plugged into the mains. Here it just says mains. It doesn't give us a voltage. It assumes that we know we should be using 230 volts. So P equals VI, we put the numbers in as before. 480 watts equals 230 multiplied by I, or the current. We divide through to get I. 480 divided by 230 gives us 2.09 amps to 2 decimal places. Again, 2 dP is plenty. Now we have to select a fuse. It's tempting to go for a 2 amp fuse because the number we're getting down here, 2.09, is very close to 2 amps. However, we've got to remember a 2 amp fuse will blow at 2 amps. If we plug this into a 2 amp fuse, then every time I switch it on, it's going to blow, and that's no good. What we actually need to do is give it a 3 amp fuse. The 3 amp fuse will allow 2.09 amps through, but it will blow if the current gets much higher. Therefore, the answer is 3 amp fuse. So question 8 is pretty much the same. We've got to identify which fuse to use, which means we're actually identifying the current. This time we've got a 900 watt vacuum cleaner, again plugged into the mains, so we know it's going to be 230 volts. Put the numbers into the equation P equals VI, 900 equals 230 times I, divide through again, and now the answer we get is 3.91 amps to 2 decimal places. Obviously this is too high for a 3 amp fuse, so we need to go up to the next one, which is 5 amps. Question 9, very similar again. This time a 2300 watt heater, again plugged into the mains, again 230 volts. So we put the numbers in under P equals VI. 2300 equals 230 multiplied by I. Divide through, the number we get is 10 amps. And here we're going to go for a 13 amp fuse. It seems like quite a big jump between 10 amps and 13 amps, but fuses don't come in other numbers, so it's going to be 2, 3, 5 or 13. So the answer's 13. So here's the last question of this kind then. We've got an 80 watt lamp. Again, it's plugged into the mains. So again, we're choosing 230 volts to put into our equation. P equals VI, numbers go in underneath. 80 equals 230 times I. We rearrange that to get 0.35 amps to 2 decimal places. So from our list up here, we would choose a 2 amp fuse. You can sometimes buy 1 amp fuses, but if the exam question is only offering you 2 amps, you choose that one. We're now looking at worksheet 15.2, which is using the equation P equals I squared R. So this is where we know the resistance and current, but we don't necessarily know the voltage. In this example then, we're asking what power is transferred when a bulb with a resistance of 200 ohms produces a current of 2 amps. Again, we write out the equation just as I've done here, and then we're going to put the numbers in underneath. We don't know power. We know that current is 2, but we must remember to square it. You'll see here, I tend to put it in brackets so I don't forget to do the squaring bit. That's the most common mistake made. Then we multiply it by 200 and we get an answer of 800 watts. So the next two questions are very much the same. Question 2 then, we're asked what power is transferred when a buzzer of 50 ohms produces a current of 5 amps. Again, I've written the equation out and then put the numbers in underneath. So P equals, I here is 5, don't forget to square it, 5 times 5, and then multiply it by 50, which gives us an answer of 1250 watts. Question 3, very similar, what power is transferred when the toaster with a resistance of 40 ohms produces a current of 10 amps? Again, we write out the equation, put the numbers in underneath. Don't forget that 10 amps has to be squared because it's I squared R, multiplied by 40 to give us 4000 watts. So question 4 still needs us to use P equals I squared R, but it's a bit different because we're being asked to calculate the current this time. We know that the power is 2000 watts and we know there's a resistance of 200 ohms. So as usual, we write out the equation and put the numbers underneath. This time I've got 2000 is equal to I squared multiplied by 200. And again, as usual, we rearrange the equation, we do our reverse maths to get I squared on its own. So 2000 divided by 200 gives me I squared, which we know is equal to 10. However, this is I squared, and we've been asked to calculate current. I now need to square root my answer in order to get the final answer for current. So now I do the square root of 10 to get the final answer of 3.16 amps. Question 5 is much the same. Again, we've been asked to find the current. We've got a 24 watt heater and a resistance of 80 ohms. So once again, we put our numbers into the equation. 24 is equal to I squared multiplied by 80. We reverse maths to get 24 divided by 80 equals I squared, which is 0.3. But of course, this is I squared, and I now need to square root the answer in order to get I on its own. So the square root of 0.3 gives us 0.55 amps to 2 decimal places. And once again, we're calculating current. We've got a 600 watt iron, a resistance of 60 ohms. We put the numbers into the equation. 600 equals I squared times 60. Divide through to get I squared is equal to 10. Again, we've got to square root it because I squared isn't what we're looking for. We're looking for I. The square root of 10 is 3.16 amps to 2 decimal places. Okay, so this time we're now being asked to find the resistance of the bulb. So far we've used P equals I squared R to find either the power or the current. We're now looking for resistance. We've got a 24 watt bulb and a current of 3 amps. Just the same as our other questions then, we're going to put the numbers in first, not forgetting that we have to square the current, so it's 3 times 3. When we do that, we then reverse maths it. We've got 24 equals 9 times R. 24 divided by 9 gives us R, which gives us 2.67 ohms to 2 decimal places. So question 8 is much the same. We've got a 2300 watt heater drawing a current of 30 amps. We're asked to find the resistance. So again, we put our equation down, put the numbers in. Don't forget to square I here. So we end up with 2300 is equal to 900 times R, divide through, and we end up with R is equal to 2.56 ohms to 2 decimal places. And again in question 9, again we're looking for resistance. So we've got 900 watts and a current of 20. We put our numbers in underneath the equation, not forgetting that we have to square 20 because it's I squared. That ends up with 900 equals 400 times R. We divide through, 900 divided by 400 is R, which gives us 2.25 ohms to 2 decimal places.